And then what we're going to do is draw the demand curve for this particular item, which should also be consistent economically. Okay? So we'll start by first specifying what the model's going to look at. This is very typical of how you begin economic research. You go out and you get data and you estimate a regression coefficient. So our model is going to look like this. We want to get a model for units sold, Q. The Q is equal P0 plus V1P, which is the price, right, plus V2N, which is the market size, plus V3, the price of competition, we'll call PC, the competitive price. Now, before we get into this, let's take a look at these. The B0s are what we want to get. B0, B1, B2, and B3. Just we have this one. Then we'll have a forecasting equation. But the first thing we want to look at is the signs of these coefficients. And we'll start with the first one, B1. Should that be a plus or minus sign? Very basic economic question. The first thing you learn in economics.
Plus.
No. Minus.
50% chance.
Prices go up, quantity goes down. They move in opposite directions. Right? If your price goes up, the amount you sell is going to go down. If your price goes down, the amount you sell is going to go up.
I understand the question.
If you go into Bloomingdale tomorrow,
I'm going to.
and you see any leftover bathing suits, they want to get rid of them. They're going to go back on the market in January when people go down to Florida for winter. But right now they want to get rid of the old ones. So how do they get rid of them? They put the price down and they sell them fast. Okay?
I'm down.
So that, you would expect the B1 to come out of negative. Now what about market size? Should that be a plus or a minus? What? What is it? Positive. Why? If the bigger the market size, the better chance you have of selling more. Right. He's right. 100%. All right. What about your competitive price? How will that affect your sales?
Should be negative.
If the suppose the competitor raises their profit, what's going to happen to your sales? You're going to get more. So if the competitor's price goes up, you go up. If the competitor's price goes down, you go down. So we have a positive sign.
Got it.
All right? You got to think these things out. Otherwise, you're liable to make a big mistake. That's the purpose of economic theory, which way the sign should be. Good. Now let's do this regression. Anybody know Sheriff Fisher?
I know him, I don't see him. I have this email and
I'm going to see. We want to do it before next Friday. All right, now let's put this together. In order to make this work in Excel, I have to put all these things together. these three together. Alright? So I can eliminate that. We'll eliminate this. And eliminate this. Eliminate this too. Okay, so these are the three x's. This is x1, x2, and this is x3. And this is the y. Now let's see if we still have our regression code for, it's still here. So what's the y range that these numbers are? So over here, the x range will be all these numbers here.
The Y range is here.
We took the 6-minute one, number 3.
Yeah.
We have the labels and the output range. We put it all over here. Back up. So now we have an equation for projection. Right?
Shit.
Let me first write out the equation.
So Y range is
Q is equal. Here's the intercept. P0. Here's the P. This is B1. And it comes out with a negative sign, like we want. That's your product, right? The next one is this one over here,
what was the Y range?
coefficient of water size. The last one is this one. This is space here. Then it's a piece. So there's our equation for forecasting purposes. But before we use this equation, we want to see how it looks.
What was the Y range?
Q.
All right?
So that would
Let's see
take
how that
the X
equation-
range.
The first thing we want to look at is
P?
P
the
and
P
PC.
test.
PN?
And PC.
Now the first P test, let's put the T test in here underneath it. So the first P test is this one. The second one is this one. Third one is this one. And the fourth one is this one.
You saw that?
Yeah.
And put them in perspective on.
Call these the T test. Now, the first one is 6 for the B0 term. Now 6 is way beyond 2, it's way out here. So we reject H0, and we reason that that coefficient is greater than 2. So we're happy with that. Okay. The second one is -9. It's way to the left of -2. We reject H0, that means we're happy with that coefficient. The next one is 12. Way to the right, we reject H0, and we're happy it's not equal to 0. All right? And the last one is 2.12. It's to the right of 2, barely to the right, but we still accept it. We'll take it. So we satisfy in all cases that we have coefficients that are significantly, from a statistical point of view, different from 0. So let me show you the standard errors. Here are the standard errors. These are the coefficients. And I'll show you how we get the theta. We get this t value. We take the b over here and divide it by the standard error here. And we get that number.
You leave the cookie. You want to fill
And
it
each one of these, we take this and divide it by this and we get that. These are the standard errors that I showed you that. So that's how we get that.
Seems like 2 hours.
So now we're happy. Oh, great. We have coefficients which are all statistically not 0. So we can use them in our model. Now the next thing we want to look at is the model as a whole. And for that we're going to use something called the R squared, or coefficient of determination. These three are all coefficients of determination. But the one that we're most interested in, the one we're most interested in is adjusted R squared. Now,
It doesn't come back to the
the correlation coefficient, who understands what a correlation coefficient is? Where are you people who study statistics? What is a correlation coefficient? What is the range of a correlation coefficient?
He used to be.
Have you ever heard of correlation?
Isn't it 0 to 1?
No. Correlation vary from -1 to +1. -1 to +1.
So close.
All right? Now, if correlation is 0, what does it mean? Suppose we say the correlation between smoking and cancer is 0. What do we say?
There's no relation.
Nobody
No
dies.
relationship.
Nobody
Suppose we
gets
say the correlation between smoking and cancer is 1. What do we say? It's a very high relationship.
A lot of people die from smoking.
Suppose we say it's -1.
Inverse equation.
What does it mean?
Inverse.
What does that mean?
Smoking would be good for you, like.
The more you smoke, the less cancer you get.
Yeah,
That's what it would be.
that's good.
So we know what a correlation coefficient is.
Right.
Now suppose you take a correlation coefficient and square it. What will be the range of values?
0 to 1.
0 to 1.
0 to 1.
All right, because when you take two negative numbers and you multiply them, you get a positive.
Positive.
So now you narrowed it down to 0. That's what the multiple regression is. It's a squared correlation coefficient. Except that we play around with regression to adjust for things like the number of observations that we have, the number of variables that we estimate. So that's what they call adjusted R squared. Now, when we see a correlation coefficient, the adjusted R squared is 0.935452. The way you interpret that, it says that this model, these three variables, your price, the market size, and your competitive price, will explain 93.5% of Q. It gives you a 93.5% explanation of the changes of Q. So that's a pretty good percentage. When you get that much percentage, that much explanation from only three variables, that's good enough. If it were 0.5, it only means that it only explains half of the percentage change in Q. There are some missing variables. You should go out and find them. And so on. The lower that is, the less good the model is. The higher that is, the better the model. So in this case, we have a very good model, we have strong stability, and a strong
Do I know your
coefficient.
one classmate had in high school?
You write that down.
Two classmate of mine.
Yeah.
Who was a classmate? He was a lawyer. Yeah, he did. When he comes here, you see
the R squared number. You just R squared, takes the R squared number. They're related.
No, it's not.
Now, those two things already tell you a lot. What we don't know is whether there's any kind of collinearity between the two. We haven't checked that. We're always checking those we're going to neglect. So what we're going to put down over here is this. Adjusted R S U U A R E D equal to 0.935. And that's good. You can be very happy with that kind of process. And these people. So now we have a very nice model. Now we do some what-if scenarios. Say, what if we put out our product for, say, $40, and our competitor puts it out for $42. All right? What if? And let's suppose the market size you get from the state. The state of New York, the state of Connecticut, all these states, they have economic departments where they have their PhD economists doing things like estimating the number of houses, that, size of the population, the number of houses that we live. Now let's suppose the state says, well, we expect next year to have 5. So now we can do something. We'll take this. Let's plug these in. So we get 40 times this. That gives us our price. Now, we're going to take 5 times that.
I don't know, ever again.
That gives us the market size. Now we're gonna take 42 times this.
He is unfortunate. Realize maybe Jesus right
Now, if we add those three things up and add it to this, we should get Q. To be for that, plus that, plus that, plus that. So based upon that scenario, the amount sold next year would be 61.6, less than last year. So management said, oh no, let's lower the price. We want to keep our market share. Right?
Can you,
40 is too much. Yeah.
how did you get negative 64 and the market size and everything?
How do we get this?
Yes,
The 40, which is the price, times the coefficient.
40 times.
You got it?
Q? What was that?
How did we get?
Can you just scroll over like 61?
Yeah, this, that,
How did you get 70? How did you get 70? What does that mean? What does that mean?
what does this number mean?
Yes, 70.70.
This number.
Yes.
That is the market size. Sorry, that's not market.
Market size?
That's the result of the market size times the coefficient.
And, okay.
Right?
Oh,
That's what that-
That's pretty cool.
So last time we're in
market size, right?
No, you really need to.
So you say, oh, if we go out with 40, we're gonna sell less than we did last year. So let's lower our price. So you start haggling with management, which we lowered. Let's put in last year's price. We put in last year's price, we get up to 69, better than. But then someone else said, well, maybe we can get a little increase. Let's split the difference. Let's put in 37.
Still better.
Get a little bit increase over last year. So that's how you make these decisions. These are what we call what-if scenarios. You might say, well, what about our competitors? Suppose they don't come out with 42. Suppose they come out with, say, 35 instead. Does this change when it's for the 35?
And mine went to 63.1. Where'd that go?
Your competition is going to increase by 4.
It's equal
That's
to
an assumption.
42.
It's a huge assumption. It's wrong.
It's just arbitrary.
Your company could be out of business.
Dude, I can't believe that.
This up.
He does. My reputation's going down the drain.
It really is, I'm sorry to say.
It brings us back down to 63. So you can change these and see what happens. This you leave, because this is a prediction. It comes from outside the model, done by experts, demographers, they know what they're doing.
15 to 34.
But you can play around with these prices here and see what you get. This is what you call what-if scenario. Now let's suppose, after a while, you're happy what you see.
That is given actually.
You believe that this is true and this is
That is
true.
given.
You're still gonna be okay. And therefore, you want to look at the demand curve for this product.
Doesn't make sense. It's not proportionally right.
So let's start putting together the demand curve for this product.
Okay.
Now, this number, yeah,
Professor, in 1999, if you go up, if you look at the units sold, it's 80, right? And the price is 15.
yeah.
And if you go to the next year, the price is 30 and you sell 64. How come?
That just happened, that's a year. That happened that year. Might have been advertising, might have been.
No, the
Yeah.
factors.
It's a big change.
Yeah, but this is not based upon equation, this is what you actually observe.
You're in the negative
It's an actual one.
There are exogenous factors. But it goes
Here we're using an equation based
Okay.
upon these actual numbers, proportions.
Okay.
Right? Now, we want to now put together a demand function for this product. Every firm should have a demand function for their product.
Yeah, I did that already.
Now, in order to do that, we're gonna have to leave out, we're gonna have to leave this in, we're gonna have to jump this.
Okay, cool. Thank you.
So for the demand function, we're gonna have Q equals. We have to change the constant term now, because the constant term is going to be adjusted by adding these two together. Equal to the old constant term plus the new constant term coming from market side plus the constant term coming from the competitive price. So there's the new constant term. Correct. Quantity, right, pure quantity.
no control minus 2. Total would be 19 points. So
And now we're gonna put in the coefficient over here.
that's why I must be a B+. I'd ask. Yeah, I know. It's funny,
And we're gonna put that by P. Now we have a demand function, and Q is a function of P. The problem with this, remember, the only thing that really, we're using the same coefficient for P, but we've eliminated these two variables by looking at these two numbers. We're substituting in these two numbers. Adding it. However, to do this in Excel, we're gonna have to make P the function of Q.
P is a function of Q. Right, is a function of quantity. Oh, you always
So in doing that, we'll bring this over to the
Minus
side,
always
and
a
bring the
function of
Q over
quantity.
this side. But this is a minus, when it comes over, it becomes a plus. I'll bring this over to the other side, it becomes a plus. Q becomes a plus. And then I have to divide both sides by this. So this will be equal to that